Hello, welcome to this lesson of our study of partial differentiation. Alright, so in this lesson, we'll just go through some examples of normal partial differentiation and also some that will involve implicit partial differentiation. Okay, so if you have not subscribed to the channel, kindly subscribe so that you can support the channel, like, and also comment as well. Alright, let's start. So, you are supposed to find del f del x and del f del y of the following. The first one is f of xy being equal to log of x base y, and the second is f of xy being equal to x to the y. Okay, so let's start. Alright, with the first one, I'm supposed to find fx and fy. Okay, or del f del x and del f del y. But before we start, let's know that this log x base y using the change of base in logarithm to the base e, which is the len, can be written as len x over len y. I hope that is correct. Okay, so you change it like that. When you are changing, yes, you see that you take the log of whatever expression you have to the new base divided by the log of the old base to the new base. Okay, so this is what we have here. So it means that our f of xy can be rewritten as len of x over len y. Okay, the reason is we know the differential of len, but we don't know how to use the differential of log, when we are doing this. So I don't want to disturb us with the log, but change it to the simplest one that we know and apply the knowledge in len to solve this. Okay, so simply del f del x here will be equal to um, del x of len of x. Okay, len of x over len of y. So here this can be written as, this fraction means this del x of 1 over len y, okay, times len of x. I intentionally did this because I just wanted you to know that this is how it looks like. Okay, here len y, or y here, is a constant like we've been doing, so it means 1 over len y can come out, and then you have del x of len x, meaning you are differentiating len x with respect to x, and you know how to do that. Okay, so 1 over len y times 1 over x, because when I differentiate len x, I'll get 1 over x. So this will be equal to 1 over x len y. Okay, I hope you understand this. So this is very, very simple. That is del f del x of the function given. Okay, I hope you get it. So let's go to del f del y will be equal to del y, okay, of len x over len y. Okay, and this is equal to del y of 1 over len y times len x, and here too x becomes a constant. Okay, so I can push len x out and find del y. Oh, okay, let me write it this way, times del y of 1 over len y. Okay, and the whole of this can be written as len of x times del y of len y all to the negative 1. Okay, alright, so we're just differentiating len y all to the negative 1 with respect to y. So this will simply be, okay, I have my len x already. Okay, then times, now since this is a function inside another function, we differentiate the power, which is negative 1, so we multiply negative 1 in front, then we subtract 1 from the power. Okay, so negative 1 minus 1, that will give me negative 2, then times the differential of the inside of the bracket. So we differentiate len, and that will give me 1 over y. Then if there was some y square or something, you differentiate the y. When you differentiate y, you get 1. Okay, so times 1. Alright, so this will be equal to, in effect, I have len x into negative, this len of y all to the negative 2 is the same as negative 1 to the, or negative 1 over len y all squared, okay, times 1 over y. So in effect, I can push the 1 over y out, okay, I can bring it first, and I'll get something like 1 over y, or let me bring the negative first, because negative is multiplying everything, okay, so let me use a different color so that you see it well. Negative 1 over y times, or let me put it this way, I'm writing them together, okay, negative len of x over y times len y squared. I hope you get this. So this is del f del y, okay, of this question. I hope you get this. So it's very, very simple like that. Now let's go to the second one. The second one is this, and you're supposed to find del f del x and del f del y, okay. So with this one too, let's say f is the same as x to the power y. Now we can't do anything to this. We can't actually do anything to this unless we change this to logarithm form. So if I find the len of both sides, okay, so this is where we'll get implicit. Len f should be equal to len of x to the y, okay. Now len f will be equal to y len of x. I hope you get this. So this is for only how do I call the expression of f. So this is the same as what you were doing. So this is what you're coming to work with, okay. So you're supposed to first find del f del x out of this. And now if you remember, this is the f inside here is a function of both x and y, okay, and wrote that here, that is here, okay, and its partial derivatives exist. That is why they are asking us to find it. So it means that we are coming to use the idea of implicit differentiation here, okay. So to find this, to find del f del x, we know that f here, or len of f, should be equal to y len of x, okay. So let's keep this. Now if I differentiate the whole of this implicitly using with respect to x, it will be del x of len of f, okay, equals del x here of y len of x, okay. So the whole of this will give me this. Now with this, if I differentiate f, I will get only f. I will get 1 over f, okay. It's a function of another function. I'll get 1 over f, then times, I differentiate f with respect to x, I'll get del f del x, okay. I hope you get this. So this will be equal to how do I call it, y out del x of len x. So this will give me 1 over f dot del f del x should be equal to y over x, because when I differentiate len x with respect to x, I'll get 1 over x times y, I'll get y over x, okay. So it means that this will imply that this del f del x, which is what we want to find, will be equal to f, or let me say f, or whatever, or however I want to call it, fy, okay, over x. But if you remember, in our previous lesson, we said that f is equal to x to the power y, okay. So you come and input that here, or insert that here. So x to the power y times y over x. Now comparing the numerator and denominator, you have x at the denominator and x at the numerator. So for me, this is the same as x y minus 1 then times y. Okay, or you can say del f del x here. You can write it as y x to the y minus 1. Okay, I hope this is okay. So this is the solution to that. Now you go to the next one, which is del f del y. Okay, now if you remember, we said that, let me go and show you that this one, you're coming to use this one. Okay, implicit as well. So del f with this one, this is what you get. Del y of len of f should be equal to del y of y len x. Okay, so here the same thing. F is a function of both x and y. So since f is a function of y as well, we just have something like 1 over f del y should be equal to del y of y times len x, because len x is a constant in terms of y. Okay, so I have 1 over f del y should be equal to 1 times len x, so I just have len x. Okay, so it means that my partial derivative of f with respect to y is equal to f len x. Okay, then f is what? So del f del y will be equal to, f now is x to the power y len x. Okay, sorry, s to the power y len x. Okay, I hope you can see what I wrote here, len x, like that. So this is the solution to the question that we were solving. Okay, thank you, and don't forget to subscribe to the channel. Okay, all right, see you.